Okay. But yeah, it's been really informative for me. I sort of threw my post up there on Reddit on I guess Friday. Yeah, today's Saturday. I kind of threw a lot of things at the wall there. I wasn't sure if anything of was any of it was interesting, and I got a lot of responses. So that's super cool because that's the only way you can tell what tickles people, what people are interested in. And yeah, so I'm starting to get a better sense of like some overall themes that people are interested in. It's I'm it's sort of bad because I I didn't get it seems more obvious to me now what like what people are interested in, why they would be. But honestly, when I started, I didn't. When you're in science, when you're working industry, you're always filed down to some specific task or function, and you just sort of jump from specific thing to specific thing, and sometimes, and after a while, you don't realize what just the people, the average, the person who's just interested in this stuff, just out of pure interest point of view, what they find interesting in this stuff, versus all these people who are like in industry or trying to make money off it, or are in some sort of very structured system like a university or whatever. So yeah, I've been really enjoying this. Let me see if I can switch over here. Uh, Let me. I can do better. There we go. Oh yeah, let me get my banner up too. Boom, my Microsoft Paint banner. So yeah, and I guess I'll keep saying this, but if you guys have any questions or comments or anything, just throw it in the chat. Some people yesterday were showing up and weren't sure if they could ask questions. Uh, yeah, I'm just. This isn't formal. I'm just here, kind of having fun. So, uh, you know, the the weather is bad over there. Let me know. Whatever tickles you guys. I have a tentative plan today. My tentative plan is to hit on the biggest theme. I think what all the questions were, which embarrassingly it took me almost 24 hours to realize. In general, I think, how do I say this? I think I think people are I think a lot of these questions are circling around how do games help your brain, and then the inverse, which is how can I improve my brain to play better at games. I'm sure that doesn't capture everybody's questions, but that seems to be a big thing. And I think some of the response has been because people who are generally scientists or who are doctors or in any sort of more sort of whatever authority position. I'm not really an authority position. I just have some degrees, but have been either negative to neutral on games. So I think a lot of people are kind of excited about that. So I don't know. I sound maybe a little autistic saying all this stuff a lot, but I've actually had to figure this out more explicitly because I didn't sort of get it. So speaking of which, we'll probably talk about that today too, because I see that was one of the biggest questions in the chat. Somebody even gave an award for that question. I'll find it later. And they were asking. It's one of the top rated questions, which is about autism and ADHD, and I'll definitely talk about that. I actually did research on kids with ADHD. I saw kids in the clinic, not at a specialty clinic, but when you're doing primary care, once in a while you see kids with ADHD. And one of the big experts of probably in the world at UCSF, she's an MD, PhD. She's at least an MD. I think she's a MD. She's a pediatric something. I forget her specialty, but maybe she's a pediatric neurologist. I don't remember, but she has a lab there, and I actually collaborated with her on some studies. So I can talk about that too. So I can talk about the ADHD stuff, but I think what people are really interested with that stuff is what it says about how the brain works. Because I think what we're dealing with is a lot of people, I assume a lot of people with like self diagnoses, not real diagnoses, not like they went to a doctor and got diagnosed, but people feel like they're a little ADD or a little autistic or, I mean, I feel like that sometimes. So we can talk about that because I think that has a lot to do with attention and how the brain works. So what I'm going to do first is actually start on the more general thing of brains on games and games on brains, just to make that quick. Okay, I'm going to do this with my jinky Blackboard here, which is Microsoft Paint, and I'll get some better tools for the future because this has been kind of fun. So I'm gonna get like a better setup, but for now I use my little mouse, and then I'm put this is I'll get like a drawing pad or something. But games, I have to look over at my screen to see. Okay, it's showing up. We're gonna talk about this. I'm gonna talk about this, and I don't know if you could tell this is like a little brain with here's a little sulk eye. That doesn't help, but you know what I mean. Little brain. This is a temporal lobe. Okay, I'm gonna be I'm gonna be back in like 1 second. It's kind of cold in here. I gotta get something warmer. All right, guys. Sorry about that. I'm back. I might put my earphones on so I can. Any feedback on the audio here? Let me jack it up just out of just to make sure. All right, let's test that. Maybe a little louder. Okay, thank you, OJ Yummy. Appreciate it. Yeah, let me know. Okay, cool. I got it jacked all the way up now, so I don't know. Maybe is this too loud? Is this okay? Sorry. If I could just get this out of the way with. Okay, cool. Thanks. Appreciate it. Yeah. The stream thing is crazy. I didn't realize you had to download so many widgets and stuff just to do everything. But anyway, it's been super fun. So anyway, today we're gonna talk about. I'm gonna try to kind of tackle the thrust of the questions. My sense of why people responded and tuned in and were even PM'd me so much, and that actually helped because like for instance, I see like some people. I got this really nice message from somebody who said that they have a neuroscience degree, they really like games, and they're just happy that somebody's sort of combining the two or talking about them, and it got me thinking because it's to me like games are kind of the background for me, and then separate my life is I've done research. I try to inject video games into my research. People are in clinic. I try to be more sensitive to that. I haven't been in clinic, by the way, in like 10 years, but because I did my MD first and then I left. Yeah, it just didn't occur to me that I think the reaction is to how people are treating games almost negatively or as almost like a nuisance or a bad thing in society or something like that. And so yeah, Twitch is probably a good platform for this stuff. And yeah, I'll talk about it. So So we're going to talk about both of these directions. So let's just pick one. And actually, this one seems actually easier for me to talk about. So how games impact brains. And there's a lot to all these topics, so we can go back over it again. But I did talk about this in one of my comments. Let me see if I can pull that Reddit up. Let me sort by. How do you sort here? Q&A. Oh, that's awesome. So it's interesting because there are specific brain training companies that try to tackle this direction here, games on brains. The idea is that if you have and I've done work for a lot of these things in the university and in this industry, and the idea is if you know all the cognitive functions, everything from vision to working memory to memory, in theory you can practice a specific skill over and over and over and you'll get better. And it's not unlike, they like using the gym metaphor. If you try to increase your vertical, you do explosive movements in the gym, right? So, with your legs. So their trainers will, which might be different than doing like slow compound movements in legs. I mean, I'm not a huge gym person, but I'm aware enough. Like I've done a little bit of training. So people like using these metaphors because it's more physical and easier to grasp, and sometimes with the brain stuff. So there's a lot of studies that show, like for instance, if you take old people, you can train their visual perception. So this is confusing maybe because it's not like we're making their eyesight better. I mean, we are making their eyesight better in a way, but we're not LASIKing their eyeballs. We're not affecting the lens of their eye. So if corrective lenses, all that stuff, that's a problem with the light not focusing and hitting your retina correctly. But assuming that's corrected to some extent or is fine, there's a bunch more of. Let me start. So you got your eyeballs, and then there's all the lens stuff that happens here, and then there's the retina in the back, and then of course you got an optic nerve, and this goes to the back of the brain, and you're gonna see my brain over and over. And so back here is your visual cortex, and immediately there's layers that it starts filtering through, and these layers are. I'm just gonna blow this up. Can you see that? And yeah, there's more or less in all areas of the brain, the cortex has 6 layers. And so as you go from V1, they call it, to V2 to V3, you get into edge detection. So there's the first layers are really seeing what's bright and what's dark on this image that's being projected from the retina. And obviously you have 2 eyeballs, so they get projected to each side of the brain. And that just feeds forward into edge detection, and eventually you get to shapes, and then there's separate streams that are more sensitive to color, and yeah. So it's not the point. The details aren't important. The point is, this is in general how the brain's always working, like at all parts of the brain, because once you get to the very say last parts of the visual cortex, like V5, V6. You've identified shapes, you've identified motion and direction of motion. And now these feed forward to more like parietal areas, which are over here. And then, yeah, well, anyway, I was going to start drawing out the whole brain, but let's not do that. And those are more higher abstraction centers. So like, you have object detection, like you have a face area. There's literally an area in your brain that's pretty sensitive to faces called a fusiform gyrus, or a fusiform area, FFA. There's the PPA, which is the pericampal something, I don't remember anymore, but that's more sensitive to places or scenes. If you see like a photo of a house or a beach or something, if I show you like 100 photos of that in an fMRI scanner, and I compare that to 100 photos of the face, the PPA will be pretty strong for the places and FFA for faces. So that's like a common cognitive neuroscience experiment. But the point is, we're trying to, so these are literally thousands of articles and tiny little studies trying to tackle this over and over and over. But the overall theme, which I assume what is more interesting to everybody here, is how's the brain working? And maybe even that's not interesting. The point is like, what do we do about it? And the reason I'm going through all this is because in theory, what you can do, so on top of this feed forward, so you have this whole thing that's called a feed forward process, where it takes the raw sensory information and you get more abstract. Like you up to a certain point, you can identify, say, let's say faces. We'll make a little. You can see that, right? Okay, cool. So you might identify like a bunch of faces in a picture or a crowd or situation, and then up here you might have a higher abstraction, which is like you identify this as a crowd of people, which are made up of faces, and so there's higher and higher levels, and eventually you get to like language centers, which are very abstract. Like our language is very abstract. The point is, there's this feed forward thing that takes raw information and essentially stripping out detail at every level to create a slightly higher abstraction. Now, that's interesting because you can train that. You can train all the different layers of that in theory, which is what a lot of these interventions try to do and scientists try to do in labs. I mean, some scientists, most scientists just work on trying to elucidate the mechanisms. Another thing that's happening in the brain, because it doesn't just have this feed forward process, it has its feedback process. So there's, and that's where we get from the prefrontal cortex, kind of monitoring everything, and that's attention, which is a big thing, which we're going to get into next, which is all the attention disorders, because attention is sort of this monitoring station. You know, and literally there are neurons projecting from your frontal cortex into all these different parts of your brain. I'm trying to think how to organize this without overwhelming or being boring. I'm not sure if I'm being interesting to anybody here, but so okay, maybe we'll zoom out back a little bit, and I'll try to make this a little more accessible. But we can get into these details if we're interested later. The point is that so there are basically, I would this is how I think about it. There are programs that train this, which is like the neuroscientists will call feedback processes, literally neurons going from the front to the back of the brain. And I don't know if maybe this is not even clear to you guys. I'm just going to redraw the brain up here again. So you have your eyeball, your eyeballs, two eyeballs. Look at that. I'll even put a little nose. And then this is like the back of the head. Oh, wow. It's not in on the screen. There we go. This is the back of the head. This is the front of the head. Okay. So this when I'm saying prefrontal cortex, that's this. When I'm saying the visual or occipital cortex, that's this. So just to make that clear. So there's these feedback ones that I'm going to say are just really attention training programs, which is a huge topic. Attention has been written about and studied for, I mean, probably a couple hundred years, actually, at least from a philosophical point of view and even from a scientific point of view for 100 years. I guess, yeah, what's his name? William James, psychologist from like 120 years ago. He wrote about this stuff. You know, the idea of conscious to subconscious, you know, kind of intersects with this area. Anyway, so a lot of the disorders, which I will probably transition to talking about, which I wanted to do because I saw that was a top-rated comment, were about ADHD and autism, and those are really just some of those. These are a really combination of these two processes, but a lot of these are attention disorders. I mean, ADD obviously is attention disorder because of the way it's labeled, attention deficit disorder. These feed-forward processes are all kind of perception, abstraction. There's a lot of different labels for it, and I wouldn't get too hung up on it because it's, you know, the scientists are trying to figure it out, and they're throwing labels on things. So don't get too hung up on it because the labels might not be perfect and they don't really know exactly what's going on. But I'm going to try to give you the overall picture, the cleanest picture of what we think is going on, and then tie that back into how do games help your brain, and then if I think there was definitely a group of people on the Reddit that were more interested in how do you make your brain better. I'll do that to play better at games.